So the next question here says you should integrate this with respect to x. Okay, so let's state a few things here before we solve. First of all, I have to point out that whenever you see something like this, okay, if you have something like a squared plus x squared, all right, it means that x is equal to a tan theta. All right, so this is another thing you have to watch out for. And in this case, we know from looking at this, if we make okay, before we go ahead, what is a in our case and what is x? Let's find out. So I can write this a, this can be my a. I can write this as 5 square, right? Plus, and I can also write this as 2x all squared, because if I have just all squared, I'm going to have 4x squared. All right, so it's now looking like this. It now means that if I replace this, if I replace this now, x now in this case is 2x, right? So this can be 2x equal to, and my a here is can be 5. So this will be 5 tan theta. All right, and in this case, if you have to make okay, we can also say x will now be equal to 5 over 2 tan theta. Now don't forget that we have a trigonometric identity that says the tan square theta plus 1 is equal to sec square theta. So we have to look up trigonometric identities. That's where you can find this. So now from here, if we are trying to make theta subject of formula, we can now say that theta can be equal to, we bring this one over here, it becomes 2x over 5. All right, then okay, sorry, I'm supposed to write theta will be equal to arctan or tan inverse of 2x over 5. Okay, I think that's pretty much all we need. Okay, no, we need to get dx. Okay, so we need to find dx. So let's find dx. Now we have to differentiate x with respect to theta. Look from here. Okay, so we can say that dx d theta will now be equal to 5 over 2. Whenever you differentiate tan theta, you should have sec squared theta. And in that case, dx, they make it dx subject of formula, dx can be equal to 5 over 2 sec squared theta d theta. Just bring the theta over to that place. All right. Now we have all we need to solve this problem. Let's go ahead to substitute. So we have gotten dx to be 5 over 2 sec theta square. All right, so I can just bring that 5 over 2 out of this place, right? I can bring it out, and what I have here is just sec square theta, all right, d theta, all over, I have 25 here, so I can say this is 25 plus, now don't forget we have 4x squared over here, and remember we know x to be what? X is 5 over 2 tan theta, so we can substitute that. So we can have 4 into 5 over 2 tan theta all squared, because of this square here. And I think that's pretty much it. So continue, just continue simplifying this until we've gotten our final answer. It's 5 over 2 to the integral of sec square theta all over, okay, so this is 25 plus, if I open this bracket, if I square this bracket, I should have 5 over 2 square should give me 25 over 4. So I have 25 over 4 tan theta squared, right? Now, okay, I can go ahead now to simplify the brackets. I'm sorry, simplify the expression further. 5 over 2 and the integral of sec square theta over, this is 25 plus, now I can know 4 can cancel 4 here, so I have 25 plus, what do I have left? Oh no, okay, what do I have left? I have 25, sorry about that, I have 25 tan square theta. All right, so I go ahead, I say this can be written as 5 over 2 to the integral of sec square theta over, now look at the denominator here, I can factorize this, right, because 25 is there and it's HCF. This can be written as 25 into 1 plus tan square theta. All right, so I forgot to add the d theta here, so sorry about that. So I have d theta. Okay, so this is equal to 5 over 2, the integral of sec square theta over, now don't forget that we initially said that tan square theta plus 1 is equal to sec square theta, so we can also apply it here. We are seeing 1 plus tan square theta, and we can replace it for what? Sec square theta. So this can be sec square theta d theta. So watch, sec square can cancel sec square here, and what do we have? We have that this is equal to 5 over 2 is the integral of 1 over 25. Okay, we still have a d theta over here. Now I can bring out this 1 over 25 outside and to multiply 5 over 2. We know that 5 over 2 times 1 over 25 should give us what? 5. Okay, now if we do this, 5 into here is 1, 5 into here is 5. So I should have 1 over 10, right? So this 1 over 10 into the integral of 1. I see I will have a 1 here. Let's just put it there for convenience sake. 1 d theta. All right, and now so let's go ahead to integrate to 1. If we integrate to 1, we know it's with respect to theta, it's going to give us what? Just theta. So 1 over 10 plus theta.
All right, so I just noticed at this point of the tutorial that I made a mistake. It's not supposed to be 1 over 10 plus theta plus c. It's supposed to be 1 over 10 theta plus c, because it's a multiplying instead of adding. So please change that. Just remove the addition sign and put and just make it 1 over 10 theta plus c instead. So that means the answer will now be 1 over 10 arctan of 2x over 5 plus c instead of 1 over 10 plus arctan of 2x over 5. So remove the plus and just make it 1 over 10 arctan plus c.